Right, good morning ASs. We're going to continue exercise 9b and we're going to be doing question 4. Now question 4 says that we have a triangle with the following 3 points, 1, 3, 5, 1 and 7, 5. Okay, and so we can have a look here quickly. The 1, 3 point is A, so I'm just going to mark here quickly for us. That's an A. Oh, it was horribly drawn. Let's just do that again. And then this is B, and that's C. And they ask us to prove that this is a right angled triangle. So I think the first thing we want to do is we want to look at gradients. And let's use the gradients of the different lines. So we know the formula for gradient. It is change in y over change in x. Okay, I'm just going to write over here delta y over delta x, and let's do it for each of the lines. So let's go with BC, and then we'll do AB, and then we'll do AC as well. So what is BC's gradient? Well, the change in y is 5 minus 1, or if you want 1 minus 5, depending on which way you go. Let's go the BC way. So we'll go 1 minus 5, which is minus 4. And then we'll go 5 minus 7, which is minus 2. So minus 4 over minus 2 is a gradient of 2. Okay, and then we're going to do AB. So from A to B is 3 minus 1, which is 2. And 1 minus 5, which is minus 4. So that is minus a half. And just to do all of them, AC as well is 5, or 3 minus 5, which is minus 2. 1 minus 7, which is minus 6. So that's minus a third. Now, if we want to find a right angle, we've got to find two gradients that when you multiply them together will give you the answer of minus 1. And we can see that the 2 and the minus a half over here will give us a multiplication of minus 1. So when we do those, we can then safely say that this is a 90-degree triangle between BC and AB. Okay, that asks or answers the first part of the question. Now, the next part says, now show or prove that the triangle is right angle and hence the coordinates of the center of the circumcircle. Okay, so we've got to find the circumcircle of this triangle. That means we're looking for a circle that goes right around this triangle. Let's try and draw one. Something like that. Okay, it's not a very nice drawing. I'm going to give it one more go. And let me just have a look here quickly. Alright. So, if you draw that circle, it must go all the way around. And the question now is, okay, it must touch each of the 3 points, which I've sort of done, but the question is now how are we going to work out the center of this circle? Okay, because the center must lie somewhere, obviously near the center here. Okay, but what do we do? What information can we use? Well, one of the things that you should have recognized is that since this is a 90-degree triangle, this line over here must be the diameter of the circle. Because remember, the angles in a semicircle are 90 degrees, and we have a 90-degree subtended angle at B. We've just proved that it's 90 degrees. So if that line AC is the diameter, then the center of that must be where or the midpoint of that line must be where the center of the circle is. And so all we're really asking here is find the midpoint of AC, which would have been an easy question, but they've asked the more difficult question, and they've asked you to recognize what is being asked here. So what is the midpoint of AC? Well, midpoints, we add the two x points together. 7 plus 1 is 8, and half of 8 is 4. So there is the one x point, and for the y points, 5 plus 3 is also 8. So 4 has to be the center of the circumcircle, or the circle that goes around the 3 points of our triangle. So that is question 4. We're also going to quickly look at question 5, so let me clear all of this stuff away quickly. There we go. Now question 5 says that AB and CD are two chords of a circle that cut at E. Right, so again we've got a circle. Let's try and draw one here. I'm hoping that the program will help me draw a nice circle. It's not doing what I wanted to do by making good circles, but anyway, that's fine. Let me just see if I reset this here quickly. Try one more time just to get a better circle. There we go, and we've got a better circle. Right, so that's our circle, and they want us to draw lines AB and CD which meet at E. So AB and CD are two chords that cut at E. So let's draw, and we can use our ruler for this one. Let's draw a line here, and let's turn our ruler. Not quite sure how to get the ruler to turn. It's not turning the way I want. Oh, there we go. If I take it at 2 fingers, it'll do it. And let's cut another line over here. There we go. And now we've got two chords, and you can see they are cutting at a specific point. So we'll call this point A and B, and then C and D, and they're cutting at E. So we've just drawn what they've asked us to draw. Now they say show that the triangle ACE and BDE are similar. So in other words, we're going to make a triangle shape now, and I think we can possibly use the ruler for that again. Let's draw our ruler point here. There we go. So there's the one triangle, and we'll draw the other one over here. Right, okie dokes, and that gives us two triangles. Now we've got to prove that the two triangles are similar. Okay, so let's see, what do we have that proves that they are similar? They don't look similar, do they? But remember, similarity means that all the angles must be equal. So the first one that's easy to do is that I can say that this angle and that angle are equal. Why? They are vertically opposite one another. Okay, and we know that vertically opposite angles are equal. But then, if you remember, we have another nice circle theorem that we've learnt. These two angles are equal. Why? Well, because they come from the same points A and D. This point over here and this point over here. They both go. C goes from A and D, as does B, and therefore we have a angle that, or two angles that are equal. And we could do the same if we looked at the points C and B, and we went from there. Sorry, let me just get my screen back. C and B. So if we went from C and B, we could get to A. So let's draw A's angle in there and D, and these two angles would be equal. And of course, if you now look at the triangles and you flipped EBD around, you could see that you could actually get them to match the other triangle on the other side. The angles are equal, 3 equal angles. So therefore, these two triangles must also be similar, okay, because they have equal angles. Remember, that's the only case for similarity, are 3 equal angles. So angle, angle, angle. That is the case for similarity. Okay, so that answers question 4 and 5. Now, next video, I'll do the next questions.